All right. So we're doing a right triangle trigonometry. We kind of started this yesterday, but we got cut off pretty quick because I was talking about the new book and all that kind of stuff. I'm not going to go through that today. So if it's right triangle trigonometry, guess what we need? We need a what? A right triangle. Well, just happen to have one right there, just like magic. Just make it a little bit bigger so we can see it a little better. Oops, there we go. All right. And we did talk about this yesterday. We talked about that Greek letter. Do you remember what that Greek letter was? Did you take notes on it? Should be in your notes. Theta, right, okay. And it looks like a 0 with a little curly Q looking thing, all right? That's how I draw it anyway, all right? So it looks like the O from Orioles, doesn't it? With that thing right there. But that's a theta. That means an unknown angle, okay? It stands for an unknown angle. It's just a letter of the Greek alphabet, okay? So sometimes we run out of letters in our regular alphabet, and so the English alphabet, so we go to the Greek. So let's do this. Let's call this angle right there. Let's call it theta. And usually we save theta to represent an unknown angle, okay? So if we don't know an angle, what do math people usually do? You could use other angles too, or other Greek letters, or you could use other English letters. But like the main one, the one that we start off with is this one, and it's theta, all right? You could do this as well. I could call this angle A if I wanted to, but a lot of times we use theta. So we're going to use that a ton. So that's why we're going to do that now. And let's take a look at these. We gave, we gave some names. Oh, first of all, do I know that's a right triangle? I almost started without doing this. No, I don't. It looks like a right triangle, doesn't it? And it is, because I made it with this computer program. I made it so it is a right triangle. But I don't know just by looking at it. How do I know just by looking at it if it's a right triangle or not? What do I need? I need that little square, that little box right here at the right angle. Okay, now it's a right triangle. Everybody got it? Okay. We've done a little bit with right triangles before. We talked about this yesterday too. See if you remember. What did we do previously in this class at the beginning of the year with right triangles? What did we do? Pythagorean theorem. That's right. We used Pythagorean theorem. And I think that might be the only thing that we did with right triangles. I don't think we did anything else with them. But there's my goodness, there's whole entire, I don't know if there's an entire course on right triangles, but there's definitely whole entire chapters on right triangles, and that's what this is. This whole chapter, I believe, is just about right triangles, okay? There's also trigonometry with non-right triangles. We'll probably get to that at some point, but right triangles is where we usually start, and it's usually a little easier when we're dealing with right triangles, in my opinion. All right. So we got a right triangle. Let's label some of these because this is super important. You may not think this is important, but it's really important because you're going to hear these words all the time. So let's push that up so I have some room to write. This side right here. This side is opposite of this right angle. Now that's very important that you understand that. Okay, the side that's opposite the right angle. You know what I mean by opposite? So if I go directly across from it, right? That's what I mean by opposite. Everybody understand that? Okay, so this is not opposite this right angle. This side right here is not opposite this right angle. This side right here, AB, is opposite angle C, the right angle. Everybody got it? So anytime you have a side that's opposite the right angle, we give it a special name. We did this yesterday, so what is that? Hypotenuse. And it's very important. We're going to use that word hypotenuse quite a bit. I don't know where it comes from. I guess I could look it up. I remember one time in college, we got our pictures taken, when you go get your class picture taken for the yearbook and stuff. And the guy would always ask, what's your major, right? And somebody said English. He would have a word for him to say. But I told him I was a math major. He says, oh, okay, say hypotenuse, right? I always remember that. I don't know why. I just thought it was kind of dorky, but that's okay. Us photographers are kind of dorky anyway. So hypotenuse, so he was a non-math person, but he knew enough math to know that, people talk about hypotenuse all the time. So that's my point of that little story. Yes, ma'am.
Mr. Hammer.
Yeah, Cam.
I want to get hypotenuse.
You want to get it?
Yeah, I want to see what it is.
I don't know what you're saying. What do you mean you want to get it?
I want to get the angle for it.
Oh, well, we don't know it yet. We don't know any sides, so you can't do anything just yet. All right, because we don't know any lengths of sides, so you can't really solve for it unless you know some of the other sides. But we're not going to do that quite yet, okay? Next week, we'll do that. We'll start finding what the angle is and what... Everybody listen? So next week, this goes for everybody. I'm not just talking to Cam here. Come on, listen up. Next week, we will be solving for missing angles and missing sides, okay? But right now, this is just an intro. This is just, just setting the foundation is all we're doing right here, okay? So this is the hypotenuse. It's always going to be the hypotenuse. It can never change because it's always opposite the right angle. Everybody got it? Let's take a look at some other sides. What about this side BC? Now, what I want to do, I put angle theta right there in reference to, okay, or according to angle theta, what would this side be right here, BC, to angle theta? What's the relationship between this side and angle theta? Well, it's also what? It's also opposite something, isn't it? It's opposite angle theta. It's not opposite the right angle, so it's not the hypotenuse, but it is opposite angle theta. So guess what we're going to call this? We're just going to call it opposite. It's opposite of the angle that we're referring to, okay? You with me? All right, you got to get this foundational stuff, okay? Because if you don't catch me now, once we start doing the stuff next week, you're going to be like, what in the world's going on? All right, so this is super important. All right, you got another side right here, and we talked about this yesterday, because this is pretty much where we ended yesterday. So this side right here, it's not opposite of angle theta. Now, it is opposite something else. What is this side AC opposite? It's opposite another angle in this triangle. It's opposite A?
No.
It's opposite what angle?
Oh.
I wouldn't say BC for an angle. I would just say angle B, right? Or you could say ABC if you wanted to, or CBA. But I would just angle B. So, right, this side right here would be opposite, but it's not opposite theta. What is it? It's opposite angle B. So it all depends on which angle that you're referring to. Does that make sense? All right, so if I'm referring to angle theta, this side is opposite angle theta. Or angle A, if you want to call it angle A. Yeah? No? What do you think? Okay. Getting blank stares. I don't know if that means just keep going, Mr. Hamrick. Yeah, this is too easy. Or I have no idea what you're talking about. It's hard to read your expressions. But at least I see expressions now without the masks on, so that's kind of nice. So let's just keep going. What's this side right here, AC, to this angle? It's right next to it, right? It's right next door to this. But some people would say, well, the hypotenuse is next to this angle theta. It's true, but the hypotenuse is always going to be the hypotenuse because it's what? It's opposite the right angle. So this side right here, we don't say it's next to, we give it a nice fancy word. What's the fancy word? Adjacent. Have you ever said that word adjacent in your life when not referring to trig and right triangles? Have you? Okay. Not many young kids, like older people might say that. Like, oh, I live adjacent to the Walmart, or I live adjacent to something else, right? And that's what, you'll hear that quite a bit. Keep keep your ears open to that word because now that you've seen it here, I bet you, like on TV and movies and stuff, every once in a while somebody will say adjacent. Every time somebody does say adjacent, I always think, I wonder if any of my math kids are listening to that and think about adjacent. Probably not, but me, I'm a dork, so I think of it. So that's how it goes. All right, why is this important? Okay, it's important because what we're going to do is we're going to use these words right here to be able to solve for missing angles and also missing sides. All right, but we have a method of doing this, and this is should have made that a little smaller. Well, that's all right. I think I can fit some of this stuff in here. Let's change to a different color. I'm tired of just the black and white. Let's see where I want to go. So what they do now, everybody's got to wake up and pay attention because this is where we get into it. Okay, that was just fluff stuff. Okay, this stuff is where we really get into it. Mathematicians came up with some ratios. What's a ratio? Basically, just a ratio is a something over something. So what's something over something? Give me just a basic math word. A fraction. Okay, so a ratio is basically just a fraction. And so what they do is and it's a comparison. You're comparing one thing to another thing. All right, that's what we're doing. So what we're going to do is we're going to use these three sides right here. We're going to make some comparisons. We're going to make some fractions. So sometimes we're going to take the opposite side. Now remember, these could be numbers, right? You could actually put numbers in here for the lengths of the sides. So there's a word that represents the opposite side over the hypotenuse. Okay? There's a word that represents that ratio. We'll show it to you in a second. There's another word that that represents the ratio of the opposite over the adjacent. There's another word that represents the adjacent over the hypotenuse. There's another word that represents like the inverse of those, the backwards. So instead of opposite over hypotenuse, what's another one you could do? Hypotenuse over opposite, right? There's also another one, instead of adjacent over hypotenuse, there's another word that represents hypotenuse over adjacent. And instead of opposite over adjacent, there's another one that represents adjacent over opposite. There's 6, all right? I can rearrange those 3 things as 6 different fractions. Would you agree with that? All right? I could this over this, or this one over this one. This one over this one, or this one over this one. This over this, or this over this. Okay, so I could have actually 6 fractions. Each of those fractions, each of those ratios has a word that's associated with it. Where they came up with these words, to tell you the truth, I don't know. You got Google. You could figure it out, right, if you wanted to. So let me give you the first word. Yeah, let's use this one. The first word is sine. You ever hear this before? If you're in pre-calc, you absolutely heard it before. But even if you had geometry, I don't know. Now, you guys said you didn't do trig even in geometry. But anyway, it's the word sine. Now, we shorten it. Now, you look at it and you say, well, it's not really that long anyway. But we will have couple other words that are a little bit longer. So we shorten it to sin. Now, we don't say sin. It's not because like it's a bad thing or anything. We just don't say it, okay? We don't say sin. So when you see sin, what do we say verbally? We say sine, right, okay? But that's how it's written. But we don't usually put the E on there, okay? There's another word. I'm going to give you the words first, and then we'll show you what the ratios are. The next one starts with a C. What's that word? Cosine. That's right. All right, it's the cosine. And what do you think we're going to shorten that to? COS, right. Now, some teachers may shorten it and say, like, cos. I've heard people say that, but I always say cosine. I never shorten it. I don't shorten it to sin or cos or anything like that. I just use the word cosine. It's really not that much longer to say, but there you go. You got another word, and it's called tangent. You probably heard that word in regular conversations, right? Like me. If I'm having a conversation, especially in math class, somebody mentions hiking, guess what I do? I take a what? I go off on a tangent, right? And I start talking about hiking, all right? I understand I do that. I have no problem with it. But what's that?
T-A-N.
Yes, that's correct. So we use the first 3 letters, and we use tan. All right. Now, some people might say tan of a side or an angle or something like that, but we just say tangent. All right. So this is sine, cosine, and tangent. Now, what we do is we always take the sine of the angle. That means, what does this mean? It means we're looking at this angle, and the sine represents a certain ratio, a particular ratio. Remember we went through all 6 of those? So which one is it going to be? Well, I'll tell you right now. It's the opposite, and I'll just shorten that, over the hypotenuse. That's what the sine represents. So when somebody says the sine of an angle, what are they saying? They're saying, okay, take that angle, look at the side that's opposite, look at the side that's the hypotenuse, and then divide them. That's what the sine means, okay? It's not a variable, right? It is just a word that tells you what ratio to take on a right triangle. That's all it means. Do you understand what we're saying here? Okay. Now, the cosine is, if I can fit this in here, it's the adjacent over the hypotenuse. Should have given myself some more room. All right. So the cosine, I should put a theta right there. So the cosine of an angle, what does that mean? If you saw the cosine of an angle, that means you look at that angle, and then you look at the adjacent side, then you divide it by the hypotenuse. That's what it means. Okay, it's just kind of like a secret word. Not really that secret, but it's a word that tells you what ratio to take. I have to scoot this up a little bit. Let's bring this down a little bit so I have some room. Okay. Now, the tangent of theta, or the tangent of an angle, is the opposite over the adjacent. And guess what you're going to have to do with these trig functions? We call these trig functions, by the way. Trig functions. What do you think you're going to have to do with these? You're going to have to what? Look at me. What are you going to have to do? Memorize them. That's right. You're going to have to memorize these. And I'm going to show you a little easy way to do that, okay? And I'll show you right now. And it's kind of a cool little, it's not a real word, but it's kind of made up word. And it's this. It's SOHCAHTOA. SOHCAHTOA. Now, I had my math teacher in high school always said TOA SOHCA, which I always used for years and years. But most books, and sometimes it's not even in a book, but most teachers say SOHCAHTOA, so I'll stick with that. All right, SOHCAHTOA. Now, what in the world does that mean? Well, look at what I did right here, and look at what this is. If you can remember SOHCAHTOA, S-O-H for so, the ka is C-A-H, and the toa, T-O-A. If you can remember that, you can remember your trig functions. So, just looking at this SOHCAHTOA, what does that mean? That means that the sine, I'm going to just put letters here, okay, is equal to what? Opposite over hypotenuse. What is the C? C is the cosine. That means what? The adjacent over the hypotenuse. And what is the T? That's tangent equals what? The opposite over the adjacent. That's what it means. But this is just a little device, little mnemonic device that you can use to remember those trig functions. That's not so hard, is it? We good? That's trig. You're learning trig right now. Isn't that cool? Yeah, we haven't really done anything with it. We got to set it up first before we actually do stuff with it. It's a very practical thing. Very, very practical. You know, people say, well, I'll never use math and blah, blah, blah and all that kind of stuff. But this stuff, people use a lot. They really do. You ever see guys out in the on the roads? They usually have like a vest on, like a bright color vest. And then one guy's a tripod. It looks like he's got like a camera on the tripod. And he's looking through it. And then there's another guy in the distance holding this pole. And he's just standing there holding a pole. Have you ever seen that off the side of the road? Okay, well, they're surveyors. Now, it used to be that they didn't have computer, stuff. Their cameras weren't computerized. They actually had to do this stuff to be able to find out like how far something was, what angle something is, and all that kind of thing. All right, so people actually did this, and then now computer programmers program their devices, but I've still seen them out there with a guy holding a big old pole and somebody looking through this thing and measuring things up. So if they want to build, like a building or something, they want to make sure that the lot is square and all that kind of thing. So people actually do use this in real life. So people ask me all the time, Mr. Hamrick, why do you got to learn this stuff? Nobody ever uses this stuff. Well, there are people that do use this stuff. Will you use it? I don't know. Most likely not. But at least it's good to think through this stuff, all right? Let's do some more. Remember I said you could also go the opposite way? Remember I said opposite over hypotenuse, but you could also go what? Hypotenuse what? Over opposite, right? So you could go backwards because we only have 3 right here. Remember we said we have 6 of them all together? Well, let's list the other 6. Let's do this in a different color. These are called inverse trig functions. All right, so I'm going to go in order, sine, cosine, tangent. So the inverse of the sine is a thing called the cosecant. It's kind of weird. It's the cosecant. Now, we don't just put COS, because if we put COS, then we get confused, wouldn't we? We get confused with the cosine. So they use the letters CSC. Remember, these are inverse trig functions, which means we just flip the fraction. This is the inverse of the sine. I went in order, okay? So this is the inverse of the sine. If you want, you could do this. 1 over the sine of theta is equal to the cosecant. All right? Everybody see that? That's the inverse, which means what do? You just flip the opposite and hypotenuse. So instead of opposite over hypotenuse, what's that going to be? Hypotenuse over opposite. To tell you the truth, I don't really memorize cosecant as hypotenuse over opposite. Like I don't have a little mnemonic device to remember these inverse functions. What I do is I remember the regular trig function, and then if I see cosecant, I'm like, oh yeah, that's the opposite of the sine. So instead of opposite over hypotenuse, it's what? Hypotenuse over opposite. These are inverses. You just flip it is all it is. All right, let's do another one. What's the inverse of the cosine? That would be, I'll do this, 1 over the cosine. What's the inverse of the cosine? That would be called the secant. By the way, how do you remember which ones are inverses? Like, see how the S and the C, they're different letters, right? That means a lot of people think the secant goes with the sine, but it doesn't, right? The cosecant is the one that's the inverse of the sine. So I always think, what's the inverse of the sine? It's got to be the one with the other letter. It's got to be the one with the C, and that's the cosecant. Did you hear what I just said? A lot of people think the sine and secant go together, but they don't because they're inverses. So it's the opposite. So the sine and the cosecant go together. The cosine and the what? Follow me. Listen. The sine and the cosecant go together. So that means the cosecant goes with the secant. Okay? See, the S and the C are inverses of each other, and the C and the S are inverses of each other. They're the ones that match up. But a lot of people think the sine and the secant go together, but do they? No. The sine goes with the what? Cosecant. The sine and the cosecant are the ones that go together because they're inverses. They're different letters, right? That's an S and that's a C. Okay? This is a C and that's an S. They go together. So I shouldn't even tell you what students, their mistakes are, but this is a common thing. A lot of people think that the sine and the secant go together, but they don't. The cosine and the cosecant, they don't go together. It's the ones that have the different letters. The sine and the cosecant go together, and the cosine and the secant go together. When I say they go together, they don't really. They're inverses of each other. All right? So what do you think the letters for secant are? It's pretty easy. It's just SEC. So we use SEC for secant. And now, remember, it's the inverse of the cosine. So what was our ratio for the cosine? It was adjacent over hypotenuse. So what do you think it's going to be for the secant? That's right. It's the inverse. It's the hypotenuse over the adjacent. Scooch that up so I still see the tangent. All right, now let's do 1 over the tangent. Or the inverse of the tangent. What's the inverse of the tangent? We call it the cotangent. How do you think we shorten that one? Just COT. Very good. All right. Now, what was the tangent? Remember, these are inverses of each other. So what was the tangent? It was opposite over adjacent. TOA. Remember that? Right? Tangent is TOA. So it's opposite over adjacent. What's the cotangent going to be? It's going to be adjacent over opposite. So knowing those 6 trig functions are really, really important. These inverse ones, if I just remember the regular trig functions, I can always find the inverse just by flipping it. You see that? So I don't necessarily have these memorized right here. I definitely have these memorized right here. And I use this little mnemonic device, right? You know the word mnemonic? It actually starts with an M. Mnemonic device. You ever see that word? Okay, it just means, you've probably memorized stuff like that, right? Where you remember like the first letter and you make up some word for it, right? Anyway, that's what that is. So, SOHCAHTOA. There we go. And I know you're dying to find out what this is used for. Like, how in the world are we going to use this, right? You're probably thinking, why are we doing this stuff? This is stupid. But it's not stupid. Remember I said earlier, it's very practical. It'll help us find missing sides. It'll help us find missing angles. And that's what this stuff is all about. That's what trigonometry is about. Finding missing angles, finding missing sides, and that's what we're going to try to do. So I won't spoil the fun. I'll just wait till Monday to show you some examples. So there's no homework since I didn't do any examples, but that's a good start. That's a good foundation. All right, and there you go.